So what is the last class? Sainath, what is our last class?
Sir, visualizing data, sir.
What about probability? Probability is also done.
General multiplication rule.
Yeah. So you can go through this particular probability, okay, articles, and you can learn it. Okay. Now we would like to know concentrating on the variables. Okay. So this is the thing. Study design is not needed as okay. Exploratory or response variable, sampling methods, and what is representative sample, what is sampling from matched fit design, and the free test and poster design, split float design, and this thing we don't need it at this moment. Okay, so if anything sampling techniques we will talk in a sampling distribution time. Okay, but this time we would like to concentrating on the random variables. Okay, so by the time of random variables, so you already know that what exactly the variable, right? So variable means it will hold some kind of data, right? But here when you become like a data scientist or data analyst, make sure that the variables can be hold a group of data, right? It's a sequential element, it can be considered, right? So if the data it was hold some huge data, then by the time you would like to go for distribution, right? So based upon that particular distribution, there are different kind of distributions are there, which is like normal distribution, binomial distribution, Poisson distribution, geometric distribution, uniform distribution, exponential distribution, and hypergeometric distribution, negative binomial distribution, and multinomial distribution. But from all the things, most of the time we are going to be using the normal distribution, binomial distribution, Poisson distribution. Okay, and only this three kind of distributions mostly we are concentrated, and usually we are using more time. Okay, but this time is very so you can go ahead and learn multiple distribution, that's not a problem for us. Okay, yeah. So let's go for what exactly the random variable will talk now. Okay, so simply we can try to understand here a random variable. Okay, typically we can denote it with any one of the variable. Usually we can denote it with capital letters. Let us consider it's a capital X. Okay, is a variable. So you already know that whose possible values or outcomes of random process. Okay, so this is the variable, it will hold some kind of outcomes, the results of the data, it will be holding it, right? So when you do one particular experiment, you will get some kind of results, right? That particular results, and moreover that experiment you might did some multiple times. So for each time we are getting some result, that result we are holding into one a specific variable, and that you can denote it with any one of the name, but usually here we denote it with capital X. Okay, so these possible outcomes are or else this variable can be hold it can be different kind of data. Okay, there are two type of random variables we have it. One, it could be the discrete variable, and second one is the continuous variable. Okay, discrete random variable and continuous random variable. So a discrete means it's a simple thing, countable, something we can count, something we can count it, right? So that we are calling it say discrete random variable. Okay, for example, how many students are there in the classroom? Okay, so you can say it's a total 50 students or 30 students. You're giving some kind of finite number, you're giving some kind of finite number, that we are calling it say discrete, right? So here the discrete variable is a variable which can take only a countable numbers or distinct values like 0, 1, 2, 3, or 100, 1 million, something whatever it is. Okay, some examples of the discrete variables are here: the number of times a coin lands on tile after being flipped 20 times. Okay, for example, you are doing, you're tossing the coin 20 times. So by the time you might be getting some kind of number of tiles, right? So that we are calling it the number of lands on tile. Okay, when you do the same coin 20 times. Okay, so here we are getting some countable number, maybe 20 or maybe 20 times, maybe 20 times also tile, or the 10 times maybe tile, or 0 times maybe tile, right? Okay, so the number of times dice lands on a number 4 after being rolled 100 times. You rolled 100 times and you want to count it how many times the 4 has been averted. Okay, the number of defective widgets in the box after 50 widgets. So you have total the box with containing the 50 widgets. We have it out of that one. What could be the defective of okay, what could be defective boxes, right? So there we are getting some kind of count. Okay, see, so that exactly the random variable, discrete random variable. Discrete random variable in the sense we are just holding no some kind of discrete numbers. So that discrete numbers we have to go with some kind of probability. So that we can denote it or we can call it a probability distribution. Okay, for discrete random variable. So what exactly which is tell it is tell us that a probability that the random variables taken certain values. Okay, let it be a small example. You we roll a pair of die one time. Okay, we will let x denotes the probability that die lands on the certain number. Okay, so for example, probability of x1, so which means that what could be the probability of getting the 1. So total possible outcomes are 6, right? Out of that one you might be getting the 1 time, so that 1 by 6. So meanwhile the probability of x of 2, it could be 1 by 6 only. Probability of 3 also, it's a 1 by 6 only. This is the way you are able to go for find give the probability of each and every certain outcome of the probability. Okay, so this is exactly the probability distribution of for each and every element in that particular distribution. Okay, so these are the terms we need to try to be go for understand by the time of probability distribution. So there is some kind of criteria, so whether it is satisfying the probability distribution or not. The first criteria is the probability of each outcome must be between the 0 to 1, in between the 0 and 1. Okay, the probability of each outcome must be between 0 to 1 only. Okay, when you do the sum of all probabilities of each and every outcome, you will get to the exactly the one. Okay, so here we notice the probability distribution for the die roll satisfy both these criteria. Okay, the probability of each outcome, it could be in between the 0 to 1 or not. And if you do the sum of these all possible outcomes probabilities, you are exactly getting this, exactly getting where 1. Okay, so that's exactly the this is the two satisfactory criterias to make sure that we need to remember by the time of okay probability distribution. Clear, or any questions are there? So this is the probability distribution. We can visualize this with
1 minute, sir, noting them.
yeah, okay, fine. This two, just you know, this two only. Nothing much. This is very very important.
Done, sir. Thank you.
Okay. See, the probability distribution, we can go ahead visualize this with help of the histogram. So you will be getting this kind of lines. Okay. So here the probability, right? Probability maximum is 1, right? So that which is started with 0 and the maximum is it can be 1, but here it is not displaying. And we are getting the probability of the this right die, right? So you would die, you done only one time, so that we will get the 1 to 6 only. The probability of getting the 1 is it's 0.16, 1 by 6 in the sense 0.16, right? Okay, and 2 also same thing, 0.16, 3 also same thing, and 4 also same thing, so that we are getting the probability of each and everything could be equal, and that too it's a 0.16 only, more than 1.1 by 6. What exactly the 1 by 6 value that it will be showing in the graph with histogram. So that could be the probability distribution for the discrete. But when it comes to the probability distribution, cumulative probability distribution in the sense we can do the sum of, okay, so less than or equal to x less than or equal to 1. So the probability of the die, so you roll the one particular die and only one time. So the probability of 1, it could be 1 by 6, probability of 2, it's a 1 by 6, probability of 3 is 1 by 6, right? But when go for the cumulative probability distribution, each and every probability, it could be sum of the previous probability. Okay, so the probability of it's x less than or equal to 1. So what could be the probability of x when x value is less than or equal to 1? So we will have only one, right? Probability of x only we have it, right? Probability of 1 only we have it, right? That is the 1 by 6. Now x less than or equal to 2. So x less than or equal to, in the sense it must be less than or equal to 2. That means equal to 2 or less than 2. So less than 2 we have only one, right? Probability of 1 and probability of 2. When you do the sum, then 1 by 6 plus 1 by 6, it's a 2 by 6. Next, probability of x less than or equal to 3. So there you might be getting the sum of the probabilities of the below 3 or exactly below 3. Okay, so 1 by 1, probability of 1, probability of 2, probability of 3. So 1 by 6 plus 1 by 6 plus 1 by 6, it could be 3 by 6. Probability of 4. So probability of 1 plus probability of 2 plus probability of 3 plus probability of 4. So that's a 4 by 6, right? So this is the way you can able to go for do the probability of each and everything. It must be less than or equal to that particular value. Okay, the probability that it can be die lands on a 1 or less than, or simply it's a 1 by 6. We cannot land the number of less than this one. So this is the probability of the lands dice 2 or less than that one. So probability of x 1 plus. So this is the explanation for this thing. And when you do this visualization with the histogram, this is the probability of 1, this is probability of x less than or equal to 1, this is the probability of x less than or equal to 2, this is the probability of x less than or equal to 3, and so on. So maximum we are getting the one only, right? So this is the probability of x less than or equal to 6, which is a combination of the all. Okay, so this is exactly a discrete cumulative probability distribution. Now we are talking about continuous random variable. Continuous random variable in the sense you will be getting the infinite possible thing, infinite number. Okay, infinite of possible number. For example, you want to find the weight of an animal. So weight, when you go for the weight of any animal, so it might be 50.6 or 50.7 by, right? So, and the height of the person, so it was in inches or feet, right? So there also you might have some kind of a floating number, rational number. Time required for the run the marathon. So here we have thumb rule for, when you can count the number of outcomes that we are working with a discrete number. Example, continuing the number of times a coin lands on the head. But we can measure the outcome. You are working with the continuous random variable, measuring the height, weight, time, and etc. Okay, so probability distribution for the same thing, you would like to go for probability distribution for the continuous random variables, and it was telling us probability of that random variable taken certain values. Okay, see here, for example, we are burger might actually weight 0.25001 pounds or 0.24 pounds or 0.48 pounds. The probability that given the burger weight exactly 25 pounds is essentially 0. Okay, so the weight, it is not constant, right? Maybe the burger weight, it exactly measuring of it's impossible to exactly 25, right? Maybe it can be more or it can be less. So that's the reason we cannot finding the probability of for exact value. It can be essentially 0. Okay, those could only use the probability distribution to tell us the probability burger weight less than or more than, right? So that make sure that we need to go for cumulative probability distribution only for this kind of examples. Okay, clear, right? For discrete random variables, we can go for the probability distribution or we can go for the cumulative distribution. But when comes to the continuous probability distribution, we cannot give the exact probability of one certain value because of it. Ideally, it's impossible. Okay, so that's the reason we can go for the cumulative probability distributions only for the continuous thing. Clear, right? So here we have differences between the cumulative distribution function and the probability distribution function. So this we already explained about discrete random variables, continuous random variables, and probability density function for the okay, and random variables, and cumulative distribution functions. This is CDF, cumulative distribution function for the discrete values. Okay, and the cumulative distribution function is following the properties, and the relationship between the CDF and PDF. So technically the probability density function is PDF, a derivative of the cumulative density function. Okay, so we can, I think we already seen this same thing in a previous lecture, this article which is explaining about the previous thing only. Okay, let's go for normal distribution. This normal distribution, see for example, whatever the data we have it, you can go for the distribute, we can just plot it, then you will be getting the this kind of curve. This is the bell shape, right? So when the curve we are getting this kind of bell shape, okay, and this is exactly the normal distribution. For normal distribution, we have this features, we have it. Okay, you can read these features. Bell shape, yes, of course it's a bell shape. And symmetrical distribution. Symmetrical distribution in the sense, the left side of this exactly middle one, left side and right side, it could be equal. Okay, that we are calling it a symmetrical. And mean and median are equal. So here the mean and median both are in the same. Okay, both are located at the same point. And make sure that this is the one standard deviation. The data, the distribution can be one standard deviation is 68. That means this is the variation is -1, right? Here the standard deviation is 1, right? So when you do the this distribution 34%, and the data it was distributed with this region is 34. 34 plus 34, it's a 68. Okay, about 68% of the data falls within one standard deviation of the mean. And next one is, this is the student standard deviation. We can do the 13.5, 34 plus 34 plus 13.5. If you do this, we'll be getting the 95. Okay, and for the three standard deviation, 99.7% of the data falls in between the three standard deviation. So the data it was plus or minus 3. So if you do the sum of all the distribution, you will be getting the 99.7% of the thing. So this kind of thing we are calling it say empirical rule. Okay, the last three rules points are known as the empirical rule. So you can go for any kind of interview, what exactly the empirical rule. Empirical rule in the sense, when the data it was normally distributed, by the time it was following the empirical rules, the first rule is the data it was falls in a one standard deviation, it is a 68. For two standard deviation 95, and three standard deviation it could be 99.7 percentage. This is the thing we are calling it say empirical formula. Can you please note this particular features? Done, right? So that it could be exactly the empirical rule. So we can see how to draw the normal curve. To draw the normal curve, we need to know mean and standard deviation. If we don't know the mean and standard deviation, it's impossible to plot this normal distribution. Suppose the height of males at certain school is randomly distributed, okay, with mean is 90 inches. So here the mean is 90 inches and the standard deviation is 2 inches. Yeah, the mean is 70 and standard deviation is 2. With help of these two values, we can sketch the normal distribution. So your mean is 70, right? So exactly the medial value is the 70. Standard deviation is 2, right? So 70 plus 2, it's 72. 72 plus 2, it's 74. 74 plus 2, it's 76. And next, 70 minus 2, 68. 68 minus 2, 66. 68 minus 2, it's a 64. So that most of the data, it was in between the 64 to 78 only. That is exactly the meaning of the normal distribution. In that particular school, 99.7% of the percentage of the males of the height is in between 64 to 78 only. That exactly the meaning of the normal distribution. Okay. Here, this is another example. Suppose the weight of certain spaces is outer is normally distributed with mean is 30 lbs and standard deviation is 5 lbs. Okay, so here the mean is middle wall and plus or minus 5, 30 plus 5, 35, 30 plus 5, 40, 40 plus 5, it's a 45. Next, below the mean, mean minus 1 standard deviation, 30 minus 5, 25, 25 minus 5, 20, 20 minus 5, it's a 15. So this is the way we can able to go with this particular okay, sketch the normal distribution with mean and standard deviation values when it is normally distributed. So this is exactly the normal distribution. You already know that empirical formula. So the empirical formula in the sense, so we can showing that probability distribution for each and every the deviation, standard deviation with respect to the mean. Clear? Any questions regarding about normal distribution? Even we can go for the 100 examples, that same thing which is explaining. Nothing much. So if you want to display the normal distribution with help of the Python code, so here the NumPy, Matplotlib and SciPy, this is the libraries we require, and the data we are taking the range of data. We are taking the range of data in between -4 to +4, and the difference is it's a 0.01. Okay, and now what I'm doing here, we are doing the probability distribution. Okay, probability distribution, and here 0 and 1, it is your range. This is the mean is the 1 and standard deviation is 1. Okay, so with the mean 0 and standard deviation 1, we are creating the probability distribution. Norm in the sense normal distribution. So here y is your normal distribution. Now what I'm doing here, you're plotting the x comma y. You're plotting the x comma y. So this is the bell curve we are getting for this particular program. Okay, this is the thing which is showing your program plot. You're plotting the x comma y. Okay, so when you plot this x comma y, then we are getting this kind of bell curve. And how fill the bell curve in a Python? So another example, we can see, I want to fill this plus or minus 1. I want to fill that. I want to show them actually. Okay, so you plot the x comma y, and your x fill the range plus or minus 1 and with 0.01, right? This is your x, and y is nothing but it's y in the sense your normal distribution only. So x fill, this is x, whatever x will we have it, and mean and standard deviation is 1. So this is the data we are taking, and we are filled with some color as a blue. Okay, and then we are going to be getting this kind of curve. So here, this is the normal distribution. For this particular normal distribution, the data what we have in between the -1 to +1, we are shaded with some kind of color. So different kind of ways we can do this same thing. Okay, green color. So the color of that particular line, it was green, and filled color also you can make it some another color as red or green. So the code, it could be similar only. Okay. Yep, this is exactly a normal distribution, guys. Nothing much. So by tomorrow's session, what exactly we would like to talk, we can go ahead with binomial distribution, Poisson distribution, and these all distribution you don't require it. At least binomial, Poisson, and these things will concentrate on it. Okay. That's for today's session. Once if it is done, then we can go ahead with either sampling techniques or else confidence intervals. So guys, bye, take care.